Welcome to week 4 in our lesson on bioethics and biotechnology. This week we tackle what I would call the surreal. We start getting into the topics of cloning and chimeras and other challenges which seem like a wild blend of science fiction and ancient mythology if it were not part of the historical scientific quilt that's being assembled today for the cause of bettering mankind. Ian had a little lamb. Our journey into cloning begins with the story of the 1996 cloning of Dolly by a team of scientists headed up by Sir Ian Wilmot of Scotland. Sir Wilmot claimed that while he headed up the research team, 66% of the credit goes to the late Dr. Keith Campbell for the groundbreaking event. Different kinds of cloning, however, had been going on for years. Let's begin with the obvious. Identical twins. Unlike fraternal twins, which occur when a woman releases 2 eggs in a single cycle and each are fertilized by 2 sperm cells, identical twins come from a single fertilized egg that literally splits into 2. Despite this biological splitting and essentially identical appearance, their DNA is subject to minor differences likely caused by environmental factors, which some scientists believe explains why the health trajectory of the twins is not always identical. But for the purposes of this study, this is the most obvious and familiar version of cloning. Identical twinning occurs in about 3 out of every 1,000 pregnancies. A familiar example of natural cloning in the plant world would be strawberries. They produce plants that are genetically identical to the parent plants. If you've ever planted strawberries, there's a runner that shoots out and then they come up again, and that new plant, that runner can be severed, and that new plant continues to grow, and it has the identical DNA of its parent plant. Now, in many ways, animals are like humans, and they can naturally clone through identical twinning. So you will get, identical twin cats or identical twin dogs. I'm not really sure the frequency of it, but it does happen. Cloning, however, can also be caused manually, as in this illustration on cloning a plant. The Herb Doctor website, along with countless other gardening and horticultural websites, provide similar illustrations on how to propagate or clone various plants. Those of us who are very big into landscaping, we use this technique a lot in order to create a somewhat purebred species of different plants. We've got some friends that are that her brother is the fellow who developed the a rose species that's suited for the upper Midwest, and then they essentially clone that species so that it has that same durability. Cloning plants is done to propagate the hardiest and most helpful of plants. Plants that can better survive within a certain climate, resist certain diseases, or yield an exceptional high volume and quality of edible fruit are all reasons for cloning plants. What is important to note is that the reason for cloning plants is that it generally serves the purpose of providing for human beings. You clone plants because it gives you a stronger crop, a more disease-resistant crop, a crop that produces more, a higher production level. So cloning becomes real valuable in that area. And this fits in a little bit. Now we're going to talk about Thomas Malthus when we get into the whole subject of eugenics. But right now, let's just look at Malthus from the late 18th century. First and foremost, Thomas Malthus was a minister in the Church of England. He also was a scholar who later became a professor of history and political economy. 9 years after entering the ministry, and 7 years before becoming a college professor, Malthus proposed what has since been called the Malthusian theory. The Malthusian theory suggests that the prevailing notion of an increased population is not good for the world. He challenged that notion. The idea was, in an agrarian society, if you have a large family, you have more people to work the farm, you can produce more, and so forth. But in his essay on the principle of population that was published in 1798, he wrote, "The power of population is so superior to the power of the earth to produce subsistence for man, that premature death must in some shape or other visit the human race." You see, what Malthus failed to consider in his theory development was that the ability of mankind to engineer crops through cloning and adaptation and so forth, that mankind was going to improve the ability of the land to produce more crops to provide a sustainable resource for the population. Cloning has become a valuable tool in providing increased productivity from available agricultural resources. Now we're going to come back, like I said, when we get into the eugenics section, which is going to be basically the heart of this course. We're going to talk about the Malthusian theory, and then we're going to talk about where it led to. Now similarly, cloning in the animal kingdom has permitted the propagation of animals which yield higher productivity of milk and meat, as well as better work animals. And on the emotional level, cloning has replicated beloved pets, which for many people have a very sound therapeutic purpose. Okay, so why clone in the first place? Well, as is so often the case in events that are fantastic, they tend to overshadow the intent, why we got there in the first place. Everyone knows about Dolly, the cloned Finnish Dorset lamb, but few people know why the cloning was done in the first place. According to the U.S. Food and Drug Administration, the cloning of animals serves 5 specific purposes: to nurture disease resistance, encourage adaptability to different climates, enhance desirable body features, enhance fertility, and remain current with changing market needs. With a biblical viewpoint that animals serve at the behest and for the purpose and benefit of mankind, then none of these reasons for cloning animals are problematic. Assuming that cloning can be done safely, that is, that it doesn't create a problem or danger for humans in consumption in the short or the long term, then there are no biblical directives speaking against the practice. We will talk about potential ecological challenges in a later class. Where things get challenging is when we remember that the majority of those in the science and research fields consider themselves evolutionists. For them, humans are simply a higher form of animal life. With this evolutionary perspective, applying cloning practices to humans is not necessarily problematic. For those of us who believe in creation and who believe that human beings are not evolved from a lower species, and who believe humans have an intrinsic or inherent value above all creation, and who believe humans are to have dominion over creation, artificial cloning is a problem. But even before the successful cloning of Dolly the sheep, science's trajectory already had been pointing towards eventual human cloning, as illustrated back in the 1993 cover of Time magazine. That same week, Newsweek, being still in print format, also came out with a cover suggesting human cloning was just around the bend. Now, this is 1993. Remember that Dolly was cloned in 1996. So you can see where people were already beginning to look down the path for this. But when we begin to talk about human cloning, some hair splitting begins to take place. The two terms used often to describe cloning are reproductive cloning and therapeutic cloning. The suggestion is that one kind of cloning is solely intended to duplicate, while the other kind of cloning is intended to heal. These terms, however, are deceptive. I'll give you an example. Like most controversial issues, the rhetoric of human cloning and the use of human embryos gets shrouded in doublespeak, which has led to confusion about the distinction between reproductive cloning and therapeutic cloning. For example, Mary Tyler Moore, a very popular actress, claims she opposes abortion, yet she favors using embryos for experimental work in the hope of finding a cure for diabetes. She may consider herself anti-abortion, but she draws an arbitrary line when it comes to human embryos. In testimony before the Senate Appropriations Subcommittee that was discussing stem cell research, and we talked about that in a previous class about using embryonic stem cells, the controversy around that, she told the committee, "The embryos that are being discussed, according to science, bear as much resemblance to a human being as a goldfish." Not a lot of depth in that comment. 17 months later, Mary Tyler Moore expanded her stem cell research comments to delve into the field of human cloning. On Larry King Live, the actress said, "There are two kinds of cloning right now. One is therapeutic cloning, which is for coming up with cures for life-threatening, really, really awful diseases. Then there is reproductive cloning, which is to make a human being out of your DNA and a donor egg. I am very much against that." Now, understanding her dim view of human life at the embryonic stage, which she expressed before the subcommittee, might shed some light on what she is saying here. She leaves the impression that therapeutic cloning is very different from reproductive cloning. Now, Mary Tyler Moore is not the only so-called anti-abortion person who has come out in favor of therapeutic cloning. The pro-life community was just stunned when Senator Orrin Hatch, a conservative and long-standing anti-abortion senator from Utah, came out in May of 2002 in favor of therapeutic cloning. I remember my work with the national pro-life groups. They just were horrified and they felt betrayed and so forth. So as reported in the New York Times opinion page, we read, "Senator Hatch, whose pro-life credentials are every bit as strong as the president's," this is, of course, going back during the Bush era, "concluded that the tiny clusters of cells that scientists use in laboratory experiments cannot be equated with human life. Indeed, the senator said that once he had mastered the subject, his decision to back therapeutic cloning, which could benefit millions of Americans suffering from intractable diseases, quote, was not, and I repeat, not, a close call. Although some right-to-lifers contend that the new cell created in the laboratory becomes a human life at the moment it is electrically activated, Mr. Hatch disagreed. He noted that the egg is never fertilized with sperm, and here he's talking about IVF type, either way he's wrong, and that the embryo will not be implanted in a woman's body, so there is no chance of a birth. At the core of my support for the regenerative medicine research, Hatch says, is my belief that human life requires and begins in a mother's nurturing womb," he said, echoing a stance he took last year in the stem cell debate. Okay, now understand this. What Orrin Hatch is saying is that in cloning, which is a process by which you don't mix an egg and a sperm together either through IVF or within a mother's body, but rather it's a different process. He said because the process is different, it's not really human life. He pays no attention to the fact that when you understand the process essentially is twinning that occurs within a mother's womb in those, what did I say, 3 out of every 1,000 pregnancies. And I've just always been shocked that Hatch had become so close-minded in this area. And the fact is, and this is one of the problems we have in the pro-life community and in the Christian pro-life community, is the moment somebody disappoints us like this, the rhetoric becomes strong, it becomes mean-spirited, it becomes punitive in nature, and there's been some pretty terrible things said against Senator Hatch, who otherwise has been very pro-life. But he either does not understand the process or he doesn't want to understand the process. Both Senator Orrin Hatch and Mary Tyler Moore, the actress, consider themselves opposed to abortion. Neither one supports reproductive cloning, but both favor therapeutic cloning. Mary Tyler Moore, on the one hand, argues that because the embryo looks no different than a goldfish, it is something that can be used for experimentation. A pretty weak argument. Senator Hatch, however, argues that because the embryo was created outside of the womb, it can be used for experimentation. I always refer to that as the geography argument, which is also weak. I have not found detailed explanations of why they oppose reproductive cloning, but I would suppose they feel that efforts towards procreation should occur naturally inside of a mother's body. Geography is a bad argument for judging human life. So let's look at what happens in human cloning with specific references to both reproductive and therapeutic cloning. This graphic is provided by the National Institutes of Health, and it's found in the Toledo Blade, and it provides a simple but accurate explanation of how the cloning process occurs, and then where it breaks off, where it splits. Rather than get into any detailed explanation of how the process works, this illustration makes the key point in that when nucleus from the adult stem cell, in this case it's a skin cell, is inserted into an egg and the nuclei combine, life begins. And life does begin, because if you allow it to continue to grow, you have a human being. You have a baby, you have an adolescent, you have a teenager, you have an adult. You allow it to progress towards its normal timeline. That's what it is. Cell division kicks in when those nuclei form, and then around the 6th day, you have the same situation you have in embryonic stem cell research. You must destroy the developing embryo to extract the stem cells. When you do that, you are doing therapeutic cloning. If you do not extract the stem cells, if you do not break open the embryo, and instead take this developing embryo and implant it into the uterus of a woman, who then serves as a surrogate, you are now doing reproductive cloning. This is also a procedure that we find in vitro fertilization techniques, where a woman may decide to freeze, cryopreserve a number of embryos, and then later on, if she doesn't want to dispose of them or donate them to science, they become what's been called snowflake babies, in which women can, quote unquote, adopt one of these cryopreserved embryos, and she'll have it implanted in her uterus, and then this child grows and is born. I know a few such cases. Now that's why the distinction that Senator Hatch and Mary Tyler Moore draw are very artificial. If it is a life that can be sustained when planted in a surrogate, then it is a life that is terminated if split open prior to implantation in order to harvest stem cells. So, the point is that you may use the term therapeutic or reproductive to describe the kind of cloning you're doing, but all you're describing is how it's used in the end. Once you clone, that cloned individual in its embryonic stage is a person. It's marked with its own unique DNA formula that would match the DNA of its original donor parents. Now, the average lifespan, this is kind of some interesting sidelights of how we're learning about this. The average lifespan of a Finn Dorset sheep is 11 to 12 years old. Now, Dolly, the world's first adult somatic cell cloned mammal, was born on July 5th, 1996. Her lifespan was only 6.5 years. Her official cause of death was progressive lung disease and severe arthritis. Dolly was stuffed and mounted and is on display at the Royal Museum of Scotland in Edinburgh. Her premature death continues to be the subject of considerable conjecture. Coincidence or not, Dolly was cloned from a cell taken from the mammary gland of a 6-year-old sheep. Her death at 6.5 years old means that cumulatively she would have lived the average lifespan of a Finn Dorset sheep. One objective piece of evidence cited for this theory of cumulative aging was the fact that upon death, the telomerase cells that are located at the ends of the DNA structure were short, consistent with what is typically found with aging. To explain that better, DNA continues to keep replicating itself in the body. As DNA replicates as we get older, at the end of the DNA are these telomerase cells, and each replication they get shorter and shorter. And it provides for visibly the signs you and I see in aging. And that's why there's been all sorts of anti-aging research on trying to rejuvenate or regenerate telomerase cells. So other than this observance that the cause of death could have been that you had old DNA involved, there were no other indications of premature aging. It should also be pointed out that there were 277 failures to accomplish a live birth before Dolly was born. So in other words, it makes for great science, it makes for a good TV news story, but it's a very complicated procedure. On January 13th, 2014, a BBC article reports that in the decades since Dolly had died, a Chinese genome sequencing center called BGI, or the Beijing Genomics Institute, was cloning about 500 pigs per year, meaning the success rate has jumped from 0.36% with Dolly to 70 to 80% with the cloning of pigs at BGI. In 1993, 3 years before the birth of Dolly the sheep, and years into cloning experiments, Hollywood released its blockbuster hit, Jurassic Park, which is about a fictional place in which the DNA of prehistoric dinosaurs are cloned to create an island theme park of real dinosaurs. And I would note that they are talking about, there's a new movie coming out now, kind of repeating off of this theme. 10 years later, science briefly succeeded in turning fiction into reality. The Pyrean ibex is a subspecies of the Iberian wild goat and was declared extinct in 2000 when the last known one was found in the wild with its head crushed. Fortunately for scientists, that same animal had been captured the year before and cells harvested from its ear and cryopreserved or frozen. When the body of that last known living creature was discovered, scientists began experimenting. After creating 285 embryos through cloning, a successful delivery of a female Pyrean ibex occurred in 2003, 10 years after the release of Jurassic Park. The newborn survived for a mere 7 minutes and died. The cause of death was respiratory problems, which is a common issue resulting from using cryopreserved cells. I have no update on this. I presume they're going to continue working on it. There is an interesting split in the interest of human cloning. I suspect that the prospect of replicating extinct prehistoric animals and historical figures predates serious scientific exploration of cloning for healing benefits. The altruistic motivation of healing the afflicted looks to be the primary driver of what some might call legitimate research, and bringing back dinosaurs and long gone heroes will follow if this research continues. Yeah, it's interesting. I know that there's been a lot of discussion about animals nearing extinction and scientists harvesting cells and cryopreserving them in the ideas of bringing them back. If you tour Ford's Theater in Washington, D.C., downstairs below Ford's Theater is a museum, and in there they have fragments of skull tissue and blood samples and so forth from when President Lincoln was assassinated at Ford's Theater. And you will hear people talk about bringing back and cloning Abraham Lincoln, and it would give them a chance to study a little bit what diseases he were afflicted with. And whenever you read about these stories, people are quick to point out that if you were to clone Abraham Lincoln, what you would get is someone who physically looked like Abraham Lincoln, but would not have had the same life experiences. It might get you all excited, but in the end, it's just an identical twin born, 220 years later or so. But this is the kind of weird stuff that cloning has brought into the arena of science. You can begin to play around with this. Now, it's interesting when we talk about the failure that occurred with the wild goat, with the that Pyrean ibex, or what Pyrenean ibex. There has been a lot of sarcasm going around about the fundamental basis of Jurassic Park. The ability to find ancient cellular structures and creating a clone from there. Everything I'm reading so far tells me that just is not going to happen, because with such great age, there's not enough healthy DNA there to really begin to replicate. Because remember, in cloning, you've got to take DNA nuclei, and that's what you begin to work with, and they don't have it, not the healthy stuff. But just be aware that there are people playing around with this kind of research. The challenge for us in Christian bioethics is to support the altruistic while drawing a line for the protection of human life at its earliest stages. As science has desensitized itself to the intrinsic value of human life at its earliest stages, cloning, whether for therapeutic or reproductive purposes, will always be problematic for Christians. In 2007, Sir Ian Wilmot, who headed the team which cloned Dolly, announced he was stepping away from pursuing the controversial therapeutic cloning process with human life in favor of the induced pluripotent stem cell methodology that accomplished the same replication without the destruction of embryos. And we talked about that in the section on stem cell research. While some scientists today argue that the iPSC, the induced pluripotent stem cell research, approach is too laborious, it represents a manner to pursue the curative potential of research without the life-destroying nature of therapeutic and reproductive cloning. So, this concludes our section on cloning, In our next PowerPoint lesson, we're going to examine chimeras and the three-parent reproduction manner.